Hello dear students, now today we learn the analysis of a fixed beam for this beam and draw the BMD and the SFD. Now this is a beam is subjected to 2-point load 50 kN and 70 kN, 2 meter distance, 3 meter distance and 2 meter distance. So our aim is to draw the BMD and the SFD for this fixed beam. So now first step is to calculate the fixed end moments. So now if you consider, suppose this load is separately like this. Suppose this consider is separately at initial stages 50 kN, this becomes 2 meter and this becomes 5 meter, and consider this another beam separately like this. This is easy to understand. So this is the next beam. Okay, this is again the 5 meter and this is the 2 meter. So now this point load creates, we know, the hogging bend movements at the A support, also at the B support. Also here this also create hogging bend movements at here and hogging bend movements at the here. So suppose this is called as MA1 and this we called as MA2, this we called as MB1 and this is called as MB2. So total MA is nothing but the MA1 plus MA2. So we can say that this MA is equal to, due to a point load 50 kN and plus due to point load 70 kN. Okay, so here we know for the eccentric load the formula is W. The formula is for eccentric load is anywhere MA is equal to WAB square by L square. This is our formula. So here what? Minus, because of this hogging bend movement for this load, minus, so W A1 B1 square divided by the L square. Suppose this is the A1 and this is the B1, this is the A2 and this is the B2. So again minus. So here now the formula is W A2 B2 square divided by L square. Okay, now here we know minus W, how much is for first load is 50. Now for only this load, so this becomes our A and this becomes the B. So A is equal to 2 meter. So 2 into B1 is here the 5 meter, 5 square, total is a 7 square, minus here for second load is 70. Now for this load, this is the A and this is the B. So what is the A is 5 meter. So into 5 into 2 square divided by 7 square. So this total value is, if you do on the calculator, this value is minus 79.59 kilonewton meter. Then on the same line of action, the MB is equal to what? Is first is due to this 70, due to point load of 50 kilonewton plus due to point load 70 kilonewton. What is the formula for MB? The formula for MB is W A square B by L square. If you want to find the B, so A square. If you want to find the A, then B square. So here is minus W A1 square. Is it W1 right here? Here write W2. So W1 A1 square B1 divided by L square minus because of hogging bending moment. Then W2 is 70. Same is here 5 into 2. Okay. Only what here A square. This is A hour. So that square divided by the L square is not, it is 7 square. Here is a 7 square. Okay. So if you do this calculation on the calculator, this calculation is minus 91.83. Okay. So we got the value of fixed moments MA and we got the value of fixed moments MB. Now, next question is the BMD. For the BMD, we have to draw first the free BMD, considering beam as a simply supported like this. Suppose we consider this beam as simply supported. Remove the fixed moments and assume only the beam is subjected to this 2-point load. Okay. For this, you have to draw the BMD. This is called as a simply supported beam, and the diagram is called as free BMD. So for that, what is your sigma MA is equal to 0. So what is your, this is A, B, 2 meter, 3 meter, and again this is 2 meters. So 50 into 2, we know this is clockwise movement. In this case is clockwise positive, anti-clockwise negative. So 50 into 2 plus 70 into, this is again clockwise, is 5 minus the 7 RB. So is equal to 0. We will get RB is equal to 64.28. Then if you apply sigma Fy condition, we will get the RA, that is equal to 55.72 kilonewton. So we got the value of this. RB is 64.28 and RA is equal to 55.72. Now again we have to draw the free BMD. So okay, now free BMD. So suppose this point is C and this point is the D. So bending moment at A and B, we know that simply supported. So that is equal to 0, A and B. So what is remaining is point C and point D. So bending moment at the C is equal to how much? At here C is 55.72 into 2. 55.72 into 2. So this becomes 1.4 kilonewton meter. And this force create the sagging bending moments. That is why it's a plus. Then bending moment at D is equal to, from the right side, how much this is? This RB into distance this. So RB is how much? 64.28 into 2. So also this create the sagging bending moment. This is why is a plus. So that value is 64.28 into 2. So this becomes 128.56. Okay. So we got the value of here 0. Here is 0. At here A is 114. At here is 128. Now join this. So this diagram is a plus. This is called as free BMD. And this is 11.1.4 and 128.56. Okay. Now again we draw here the fixed BMD. This is a free BMD. Then fixed BMD is what? Here is only this moment. So how much this is? 79.59, and here is 91.83. So if we draw the diagram, this diagram is because of hogging is negative, so we can say that this is and this diagram is negative because these are the hogging reaction. So 91.83 and 79.59. So superimpose this diagram over this diagram, or superimpose this diagram over this diagram. Suppose we superimpose this diagram to here. What here? Negative. This diagram is negative, and here is 79 is something here, and 91 is something here. Okay, this is 79 and this is 91.83. So this part is negative, this part is negative, and this common part gets the cancel out. So this PMD now becomes the BMD. Okay, so now remaining is the what? A shear force diagram. So now we got this beam like this. What here? This is our beam 50. This is 70, 2, 3 and 2. Now here we got one moment, that is 79.59. We got the moment at here 91.83. Now again this we have to find out the here now the calculation of shear force, final shear force diagram. For that again we have to find out the reaction, this RA and the RB. Previous one was only for the simply supported, removing the fixed end moments. Now here we want a total shear force diagram, so consider the here fixed end moments here. So now if you consider sigma MA is equal to 0 here. So what here? This is minus, because you consider is minus, and this we consider as plus. So minus 79.59, then plus 50 into 2, then plus 70 into 5. Again this is plus 91.83, and this RB we consider the upward direction, so minus 7 RB is equal to 0. If you do the calculations, this RB becomes 66.04. Previous one was how much? 64. Okay. Now if you apply here the sigma Fy condition, so RA plus RB minus 50 minus 70 is equal to 0. So RA plus 66.04 minus 50 minus 70 is equal to 0. So this RA becomes 53.96. Okay. So now we got this RA and RB considering this fixed end moments. Now we have to draw the shear force diagram. So now consider this is our beam. Now here we got the RA value is how much? 53.96 and RB is 66.04. Now shear force at here we know from left side consider. So upward force is positive. So this force is our positive 53.96. Now up to this is a constant. Suppose we up to here is a constant. Okay. Now at here shear force at here is what? RA is plus and this 50 is minus. So 53.96 minus 50, that becomes 3.96 here. Now again up to here this shear force is constant. So draw this line is constant. Now if you calculate the now shear force at here from right side. So for section right side, upward force is negative. So this is minus 66.04, and here up to this is constant. So then 66.04 here at here from the right side. But here downward force is plus. So plus 70. This is minus 66. Becomes the plus 3.96. So up to here draw this. This is minus and this is plus 3.966. This is the SFD. Okay. So this is the SFD, total SFD, and this is our total BMD. Thank you.